Okay, so chapter 2, lesson 3, still on quadratics in factored form. Day 1 of this lesson, we reviewed different types of factoring. So we reviewed the greatest common factor, we reviewed product and sum factoring, we reviewed the difference of perfect squares, and factor by grouping and decomposition. So today we're going to finish up the review of factoring with double factoring, basically just problems where you have to factor more than once. So basically a combination of everything. So on the first example, you look for a greatest common factor, and that should always be your first step, is to look for a greatest common factor. So everything is divisible by 2. Not only that, but you also always take the sign of the first term. So no matter whether this was positive or negative, it's the first term that matters. So we're going to divide by -2. When you divide, you get x squared plus 5x and minus 14. And then once you factor it out of the greatest common factor, you check to see if you can factor even further, which in this case you can, because what's left in the parentheses here can be factored using product and sum. So the 14 can be split using a 2 and a 7. So make the 2 a negative and the 7 a positive. So then it'll factor into x minus 2 times x plus 7. And the -2 that we factored out in the beginning needs to go with your answer. So there you go. That's the fully factored form of that problem. Example B, you can factor out a 3, so we'll divide out a 3. When we divide, we'll have x squared minus 6x plus 9. And then again, looks like it's going to be product and sum. So 9 is going to be 3 times 3, or 1 times 9, but since they need to add to give you a -6, it needs to be a -3 and a -3. So x minus 3 and x minus 3, and the 3 that we factored in the beginning needs to be with your answer. Example C, looks like both of those numbers are divisible by 5, so let's take out a 5, divide, and you have x squared minus 9. And again, you always want to double check to see if you can factor further. 9 is a perfect square, so this is a difference of squares problem. So x plus 3 times x minus 3. And bring the 5 down. Okay, last one, same thing. Looks like this one's also divisible by 5, so divide out the 5 and you get 4x squared minus 9. I'm looking at 4 and 9, and I know that those are perfect square numbers, so it looks like it'll be the 4x squared would be 2x and 2x. The -9 would be a +3 times -3, and bring the 5 down. So there you go. That's what it looks like to factor multiple times for the same problem. All right, so all of that was a review of Algebra 1. And all of that factoring is going to be necessary to do the actual lesson 2.3 that we're going to start now. So now we're going to be using factoring in order to find what's called the zero of a function. So the zero of a function, like you can read there, it's the number that you can plug in for x that makes the y come out to be 0. So like you plug in a number for both x's, and then for all the x's, and then your answer will be 0. So that's called the zero of a function. When you go to graph, that answer that you get, that is actually going to end up being the x-intercept of the graph. So the zero of a function can also be called the x-intercept. And in fact, all 4 of these words all mean the same thing. So if I say the word zeros, x-intercepts, roots, or solutions, they are all referring to the same thing. Now, in terms of roots or x-intercepts or zeros, whatever you want to call it, there's 3 possibilities. You could have parabolas that don't have any x-intercepts, so that would look something like this. Parabola that's above the x-axis, or maybe below the x-axis but points downwards. The most common one would be if you have 2 x-intercepts, so something like this. So you have 1 and 2. And then, doesn't happen too often, but it does happen sometimes where you have one x-intercept, and that's when the parabola basically just kind of bounces off of the the x-axis. So that vertex is also the x-intercept. Okay. So now we're going to use that factoring in order to find the zeros. So if we're trying to figure out what value for x can we plug in that will make the answer 0, then we start the problem by taking that function and setting it equal to 0. So I will do just that. I will set it equal to 0. And in fact, to be able to do any of this, it has to be equal to 0. Once you set it equal to 0, then you look to see if this can be factored, which these will be able to be factored, because this one is product and sum. So multiplies to 12, that adds to -8, so that would be x minus 6 and a -2. Okay. So now I have factored the problem. Now to finish answering, first I just need to explain this idea. I'm just going to write this off to the side. If you have two numbers that you don't know what they are, two numbers, but when you multiply them together, the answer is 0, what can you tell about those numbers? Well, if they multiply together and then the answer is 0, that tells you that one of the numbers has to be 0, or both of the numbers are 0. So we're going to use that same idea over here because we have two sets of parentheses, and when you multiply them together, the answer becomes 0. So we need to know, we don't know which one would be 0, so we just take each one individually and set it equal to 0. And then once you set it equal to 0, then you just solve each one individually. So you would add 6. On the other one, you would add 2 to both sides. So x is going to equal +6, and on the other one, x equals +2. And those are the solutions to this function. These are the zeros, the roots, x-intercepts. All of that means the same thing. So here, next one, same thing. Has to be equal to 0 in order to be able to find the zeros. Then you factor this. So 12 multiplies to -12 but adds to give you -4. I think that would have to be a -6 and a +2. Once you factored it, you would set them equal to 0 individually. So x minus 6 equals 0, x plus 2 equals 0. And on the left one, add 6 to both sides, so x is equal to +6. On the right side, you will have to -2 on both sides, so you get x is equal to -2. So there are the two roots for that one. Repeat the same thing on the last one, so set it equal to 0. Now this one only has two terms, and that 81 I know is a perfect square. So then 81 is 9 times 9, so x plus 9, x minus 9, and equals to 0. Now, I don't know if you noticed, but the shortcut to go from here straight to the answer is, it always just ends up being the opposite sign. So here we have a -2, comes out to a +2. -6, +6, and +2, -2. So as a shortcut, the x plus 9, just change it to the opposite sign, so -9. And the x minus 9 opposite would be x equals +9. So there are your two solutions to that one. And in fact, that last problem, you can actually rewrite your answer if you wanted to be x equals ±9. Now let's just do 3 more examples of the same thing, but different types of factoring. On the first one, 3x squared plus 12x, have to set it equal to 0. Actually, I'm just going to write it right there, equals 0. Then I'll cross this out. We don't need this anymore. Then it looks like this one's going to be greatest common factor. So factor out a 3 and also factor in x because they have that in common. When you divide, you have x and plus 4. Now, just like before, you can already just use a shortcut to get one of the answers. So that one's a positive 4, x equals negative 4. Now on the 3x, I'm going to actually work this one out. So 3x, you set that equal to 0, and then divide both sides by 3 in order to solve that. So then you end up getting x is equal to 0. So there's your two solutions. The middle problem looks like I can't factor out a GCF, therefore I'm just going to set it equal to 0. And it looks like this one is decomposition. So I'm going to multiply 10 times negative 3. That'll give me negative 30. Now they have to add to give you a 1 that's in the middle. So it looks like a 6 and a 5 would work. So plus 6x and minus 5x. And bring down the minus 3 and bring down the 10x squared. Just like in the previous video, I showed you how to do decomposition and factor by grouping. So I'm going to go through this next part pretty quickly. 4 terms means factor by grouping. Take out a 2x on the first set of parentheses. When you divide, you have 5x plus 3. On the second set of parentheses, you can factor out a negative 1. Divide and you have 5x plus 3. And then looks like the 5x plus 3 you can take out, and the 2x minus 1 is what's left. And then through that whole process, it was always equal to 0. Again, none of this is possible if it's not equal to 0. Now, there is no shortcut to solving them. You just actually have to solve them. So 5x plus 3, equal it to 0. Subtract 3 and you get 5x is equal to negative 3. And then divide both sides by 5. I want you to leave your answer in fraction form. So negative 3 over 5. The other one, the 2x minus 1, set it equal to 0, add 1, and divide by 2, so x equals a half. So now these are answers that are fractions. Last one. Looks like I cannot divide out anything. So again, product and sum, or no, sorry, decomposition equals 0. We don't need this anymore. Multiply 3 times 10. That's a horrible arch, is 30. So it looks like we will split the middle term to be 15x and 2x. 3x squared plus 15x plus 2x. If you don't remember how to do this, it's on the previous video. Factor by grouping, I'm just going to go through it as quick as possible. Factor by grouping, you can take out a 3 and an x, divide and you get x plus 5. On the second one, you can take out a 2, divide and you have x plus 5. So factored form, completely factored, is x plus 5 times 3x plus 2. Again, has to be equal to 0. On the x plus 5, you can just use a shortcut. X is equal to negative 5 to the answer. 3x plus 2 you actually have to work out. So subtract 2 and divide by 3, so x is negative 2/3. All right. So we'll stop there for this lesson.